Hello, everyone. Thank you for joining us today. We are going to get started. Looks like we will probably have some people joining us. We have quite a few people registered for today's webinar, but we will go ahead and get started. So thank you so much for joining us today. This webinar is presented by PIANC USA's YPCOM Commission, so that is the Young Professionals Commission, and I am Kayla Waltemeyer. I am the Deputy Secretary for PIANC USA. Just a few housekeeping issues for today's webinar. We just ask that you keep your video off unless you are speaking. There may be some time at the end for some live question and answer, and that would be an opportunity for you to turn your video on, but we ask that you keep it off until that point. All of the phones and audio, all of them are going to stay muted throughout today's presentation. If you have any questions, you can chat them in through the panel. We will have a question and answer section after each presentation that will be moderated. So we will have an opportunity for questions. You can chat those in. And today's webinar is being recorded and it will be posted on our YouTube page. So we will also link any resources or anything like that that the presenters are mentioning, so you don't feel like you have to take notes today. Just sit back, relax, and we're really excited about our presenters. And so I'm going to pass it over to Matt McCarty. He is the PIANC USA Young Professional Principal Representative, and he is going to get us started.
Excellent. Thank you, Kayla. Good afternoon, everyone. Thank you all for joining us. As Kayla mentioned, my name is Matt McCarty. I'm the current lead representative on our committee. We have an awesome seminar lined up for you guys today with the theme of soft shoreline stabilization. We have Alejandro Lira with Smith Group presenting on offshore breakwater design in the Great Lakes, and Bart Roost with Delft University and his really novel sand motor beach nourishment project. Really cool stuff. As Kayla mentioned, we have a few upfront announcements. We'll have our speakers' presentations with Q&A in between using the chat feature. A few final announcements wrapping up, and then some open Q&A session at the end where mics will be unmuted. So, Kayla, yep, next slide, please. Thank you. So this is our PIANC USA YPCOM leadership team. Myself, Matt McCarty with McLaren Engineering, based out of New York area. Andrea Viteri with Moffitt Nickel, based out of California, Southern California. Nick Stefani with Edgewater Resources in Wisconsin, Nicole Pauly with Moffitt Nickel out of Florida, and then Kayla Waltemeyer out of Washington, D.C. So after 4 years of service, Andrea has actually reached her term limit and is moving on from the committee. She's been awesome to work with, has done a lot for creating engagement and developing content for PIANC USA, especially in the Southern California region. You should be seeing an announcement, a call for new committee representations on our committee, and we welcome you to apply. If you're engaged, if you love waterfront design, construction, things like that, and want to do more, we're happy to talk to you, especially if you're from that West Coast region. But with everything being remote, geography, seems to matter a little less these days. So we'll keep going. And then just a couple quick words about PIANC. If this is the first time you're joining us for one of our webinars, World Association for Waterborne Transportation Infrastructure. It's very much an international community based in Europe, dedicated to developing global standards and communication for people in this maritime industry to help us work together. And their primary deliverable, their primary mission is to put forward these working group best practice manuals to serve as guidance in different fields. There are 7 different commissions, 4 of them technical. These working groups, there are many active ones. Many of them are seeking young professional representation on them. Again, young professional in PIANC is defined as under 40 years of age, so it's a pretty liberal definition. And there are always new working groups launching all the time, and so we'll be discussing that more towards the end. Next slide. Thank you. And then finally, as I said, it's very much an international organization. PIANC has, these are all the membership countries, over 40 qualifying members. So it's very international, very big. A lot of opportunities for coordination and hopefully back to travel with our counterparts overseas and exchange of ideas. So with that, we'll get more into the meat of our seminar here. I'm going to turn it over to Nick Stefani at Edgewater Resources. He was instrumental in organizing this seminar, and I know is excited to present it to you guys.
Thank you, Matt. So as Matt mentioned, we're going to have two presentations on soft shoreline stabilization. The first presenter is Alejandro Lira, who has worked with Smith Group the last 5 years out of their Madison office. She's their primary numerical modeler, and she's been fluent in Mike 21, S-Beach, and MEPBay. She's a key engineer in Smith Group's coastal engineering design group to support various types of projects, ranging from shoreline protection to small craft harbor design, shoreline development master plans. As Matt mentioned also, we will be taking questions at the end for about 5 to 10 minutes with questions in the chat. So if you have any questions, just either hold on to them or enter the chat, and we'll get to them at the end. And with that, I will pass it over to Alejandro.
Hello. Thank you, Nick. 1 second, let me share my screen. All right, as Nick just said, my name is Alejandro Lira from Smith Group, and I come to present a summary of the many aspects that the design of the Euclid Waterfront Park encompass. I would like to have my video on, so 1 second, please. There we go. To start with, I just wanted to present a quick overview on Smith Group and the kind of services that Waterfront team deals with on a daily basis. Today's example will be including several such as flood stabilization, numerical and physical modeling, and coastal protection in general. To give you guys some context, the project area is in Euclid, Ohio, which is a suburb of Cleveland. Located on the shoreline of Lake Erie, the population is approximately 49,000 and shrinking. Unfortunately, over 22% of the population is below the poverty line. It is not an affluent community with very few public parks. Even though Euclid, Ohio has nearly 4 miles of Lake Erie shoreline, less than 6% is available for public waterfront park space. So the city of Euclid started this project in hopes to solve the erosion problem at the shoreline and provide a community with the public access to the lake. The project area shown in this slide is less than a mile, and I'm going to quickly go over some of the sections to have a better understanding on the site. This is called the Lakeside Cove. It's an area owned by the city. It was the only natural area left. And as you can see from these images, it was experimenting severe bluff erosion. Years of neglect resulted in loss of beach, a loss of nature habitat, and threats to adjacent homes and development. In this area, we can appreciate a big part of the problem. That is because in Ohio, landowners are actually entitled up to the ordinary high water mark. They had resorted to all kinds of techniques to protect their shorelines, such as the use of refuse material that was discarded from other projects. You can see in this example that instead of a proper revetment, they resorted to throw discarded roadway pieces onto the shoreline to try to fix the problem. Another of the areas, which is actually, this is the area in front of the city of Euclid lot, so you can see right here, which is actually, it was actually a recreational area owned by the city. But there was no access to the waterfront, and thankfully, because what you're seeing in this image is not just rocks and branches, but actually pieces of concrete that had been rolled for many years and rebar that posed a dangerous tetanus threat. When the team started to looking back at the erosion, they found that the receding shoreline was not a new problem. Back in the 40s, the sediment supply was plentiful. However, the construction of man-made structures updrift had captured most of the sediment, which prevented the natural supply to the littoral system. To study the bluffs, a stability analysis was performed to see at which slope the bluffs will become naturally stable. And the decision was to carve the bluff back to become safe, and then a toe stabilization would be placed at the bottom. And it could have ended there, where the team could have opted for a typical revetment like the one recommended in the Ohio Coastal Design Manual. But the team decided to go look for other, more creative solutions to the erosion problem. Instead, knowing, as I kind of explained before, all the social circumstances of the city's population, the Smith Group and the City of Euclid decided that they could do better and provide a public amenity for all of those who wouldn't have access to the lake. They decided to create a recreational waterfront park that would use both hard and soft engineering techniques designed to dynamically adapt to the forces of Lake Erie and not impede the natural littoral transport. All right, to make this happen, the team encountered the biggest challenge other than the design of the actual coastal structures, which was to convince the 84 different owners to give up their private bluff. As part of the work, the team had to talk to each individual that owned the property, and many public meetings, open forums, talks with stakeholders were had to try to convince each and every one of these agencies that our project would work. Because of this, the whole process took over or close to 10 years, which is a little bit beyond the engineering part. Now, on the more technical side, an analysis of historic wave information showed that the waves at the project site are predominantly from the west sector, and the net sediment transfer you can see on the arrow on the slide is eastward. Also from this image, you can see the difference in depths along the project area, which results in larger waves impacting the area at the east. Once we had information of the existing wave and wind dynamics at the site, the team used this information as input for multiple numerical models that would allow us to gain a deep understanding of the coastal dynamics and therefore evaluate how different iterations of structures would affect the function of the design as a whole. This included a spectral wave model for wave transformation, a hydrodynamic model to understand current patterns around the proposed structures, a sediment transfer model to understand the differences on the littoral drift rate along the shoreline before and after the structures, and a coastal evolution model to see how the coastline would evolve after a certain period of time, given the dominant wave conditions found at the site. Once the team reached a layout that they felt confident and a solution they felt confident in, they took it to a physical model. That was done in 2016 at the NRC Hydraulic Laboratory in Ottawa. The physical model was necessary due to the size, cost, and also importance of this project. The team started with sediment transfer modeling, focusing on the morphological changes due to the structures and the change of the layouts, where they used a synthetic environment that represented the energy profile for the site. The beach sediment was modeled using both coarse and fine sand that deform naturally in response to wave forcing. Over 90 simulations with various permutations of coastal structures and beach layouts were tested that informed and supported the detailed design of the shoreline protection features. Now, just as a comparison, this is a picture of a more recent model that we did for a different project. We built it at a facility in the UK where instead of using walnut shell to simulate the sand as in the previous laboratory, this laboratory recommended the use of anthracite for its lower weight and ease of movement under the design of the wave conditions. So additionally, for the morphological test, the team opted for the use of sandbags to represent the structures. This allowed for a quicker assessment on the different configurations tested, because once the team was happy with one, the anthracite was replaced with a sand beach and the structures were actually built with rock to properly represent the real conditions And this approach saved a lot of time since we didn't have to build each structure with rock every time we needed to test a different layout. After the morphological testing, there was additional modeling to test and evaluate the stability of the proposed structures against storms of different return periods. One of the interesting things to note is that during the physical modeling, the team actually recognized that there was an area where the sediment transport direction was changed, causing the sediment to build up at that location. And this is something that was not noticed during the numerical modeling phase, and therefore it supports the need of both types of modeling for a more complete understanding of the site. Once all the modeling was completed, the design team decided to create a more holistic solution and include a lot of features that would enhance the habitat for different native species. In these cross-sections that I'm going to present, we can appreciate the different enhancements added to the shoreline, such as wood inserts, partially submerged logs that would promote habitat for species. In this case, we have a sand gravel that informed and support fish spawning in different areas. On the flora, we have submerged aquatics, wetland species. We also have a thick prairie that is going to be planted more on the upland side, creating a more complete ecosystem. And this, just as a shot, are some of the native species that live around this part of Lake Erie and whose habitat improvements were included in this project. Now, some of the original renderings for the project that show a little bit of different breakwaters, the revetments, the cobble, the beaches, and the back walkway. It is important to notice that the original owners were still able to keep their private access, as you can see here on the gated area. So they were happy about that. And this is a picture from last year showing some of the progress of the construction of the site. The bluff has already been excavated, the walkway is mainly complete, and some of the structures are in place. Another perspective of the progress. And finally, the city is using this project as an example, walnut shell to simulate the of the Cleveland coastline because it's proven to be a success case so far. As a summary, a series of numerical and physical models were undertaken to optimize some more natural design. That laboratory. This laboratory to extreme events. As we were able to see before the project began, the shoreline was very unsafe, nothing to look at, and this project successfully helped bringing for its lower weight and ease of movement a community waterfront park. And we can safely say that this place is now going to be a destination waterfront. And we'll be able to support city-sponsored festivals, social events, etc. So additionally, do you have any questions?
Awesome. Thank you, Alejandra. That was very interesting. I know I'll just ask one quick question before some of the other questions roll in. Where do you get a lot of the data for both the wind and the bathymetry for a project of this kind of scale?
There's a lot of public data available for the Great Lakes. One important one is the Wave Information Study, which they probably have over 30 to 35 years of wind and wave data for all of the coasts of different Great Lakes. That's a big one, assessment on the different configuration steps. Resources that NOAA has, especially for bathymetry, waves. There was a GLOS system which was also for waves. I'm not sure if that's up and running still. It was a great program that they had in the past years, but I know that with some cuts they've had, they had to replace with a sand beach, and it's still stopped. there's a lot of public information available when it comes to the Great Lakes. No, thank you. Rock to properly.
Okay, here, Alejandro got one more. So, do you, for this particular project, or was it a design consideration for re-nourishing the project?
This approach saves a lot of time.
Like over 10 years?
Yes, so this project had actually several phases that for time constraints I didn't go over each one of these. But there is a beach that is called, let me find it right there. There's a few beaches that were considered a feeder beach right here at the end that was considered to be designed to be re-nourished, and this beach actually was designed to be able to like provide sediment to the downdrift area so that anything that we would do here wouldn't be a big impediment to that. So I know that nourishment was considered for this. Some of the other beaches though are cobble beaches, and that's a more coarse sediment. It wasn't designed to be more of a swimming area, but it was designed to be more stable. But yeah, beach plant form, beach profile, and nourishment was all considered for this project. Oh, you're not seeing that part.
And then one more question. So, were any aspects of the PIANC's working with nature philosophy incorporated into this project's design? I'm not sure if if you guys are familiar with that at the time for the design.
I am not familiar with it personally, but probably the team members that were working more with this were. I cannot say for sure yes or no, but that would be interesting for me to look up.
And then, obviously, you have a lot of experience with numerical models. Are there any standards or specific packages of software that you would consider the gold standard? I know there's some people that are, this one particular person has had success with Delft. Are there any other models that you recommend or?
Yes, I believe the Delft 3D uses Swan as the main wave model, correct? That's a spectral wave model, and it is really good. Actually, Swan was used also for this project. We have a variety of numerical models. We have licenses to Swan. Is actually an open source software. I would highly recommend it. It really depends on what you're familiar with, and as long as you know the downsides or the shortcomings, let's say, of each numerical model and how to use it to your advantage and what the different variables mean. You can all of them are really good. I like Swan. I like Mike 21SW. Mohit for hydrodynamics. There's a lot of good open source software available. It's just a matter of you being familiar with it and knowing how to use it, so that it's not just you put something and then something comes out. You need to know all of the different variables that are related to it.
Awesome. Well, thank you again. I think we're kind of reaching that 5-minute mark, so we'll thank you again. We'll transition to the next presenter. If we have time at the end, we'll probably try and get to some of these other final questions that are kind of rolling in. But at this point, we'll transition to our second speaker.
Sure, sounds good.
Thank you. So now we have Bart Roost, who is a coastal engineer from Delft University of Technology in the Netherlands. His master's thesis was about the morphodynamics of the sand engine and its relation to the surrounding coastal cell. Currently, he is pursuing a PhD at KU Leuven in Belgium, focusing on the morphodynamics of the Belgian coast, and he was involved with the project called Sand Engine or Sand Motor, and that is what he will be talking about next. So with that, I will pass it over to Bart.
Yes, wait for that. And start the video too. Yes, thank you. Thank you, Nick, for introducing me. Welcome, everyone. My name is Bart Roost, and I'm going to give a talk about the sand engine, a big nourishment along the Holland coast. And this presentation will focus mainly on the morphological aspects of that nourishment. However, there are many, many more things to tell about. So this is me. I graduated indeed from Delft University of Technology with a master's in coastal and hydraulic engineering, and I studied the morphology of the sand engine. And currently, I'm a PhD researcher at KU Leuven in Belgium. That's the country just south of the Netherlands. And I'm currently studying the coastal morphology and the effects of coastal nourishment. So today's talk will be about the sand engine, but before diving straight into that, I will first talk about a little bit about the Dutch coastline policy and what all led to this big nourishment project. So here we have an overview of the Netherlands with a map with altitude indicated. And all of these blue areas are actually located below mean sea level. That means that without any protection measures such as dikes or dunes, these areas would be subject to flooding. And that's why coastal protection here in the Netherlands is quite important. The image in the background actually gives a view of the coast as it was well before implementation of the sand engine. We see a sandy beach with some dunes behind it, and very close to the coast already we have a lot of coastal settlements. In this case, we're looking to the suburbs of The Hague, our main city. And also visible here are groins. These groins are placed there to actually mitigate or reduce coastal erosion. To further characterize this coast and let's say give it a slight indication of what the area is we're talking about. The Holland coast is located in the west of the Netherlands. It's kind of an interrupted coast, which is characterized as a sandy beach and dune system, and it provides protection against flooding of the hinterland, where several million people live. However, it is subject to structural erosion, and already for some centuries we have taken some measures against that. One of the first things we did was building groins on the beach, which helped to a certain extent. And also the Netherlands are famous for their
that live around this part of Lake Erie.
The dike on the upper right figure actually isn't there anymore in this situation, since it has been replaced by a mega nourishment as well. Well, the dike is still there, but there is a lot of sand with it. and of course the delta works, which are shown below. But those are all well, examples of traditional hard engineering solutions. They are there, they do their work for a long time. However, they are fixed, so if boundary conditions change, things may get very, very expensive to replace or improve these situations. So that's why there was a shift towards the so-called soft solutions. Soft in this view means that we use sand or sediments in general to provide improved protection against coastal flooding. This started in the 1970s with mitigation of storm damage and some sand nourishments for recreational purposes, and this migrated to actually a policy or a law which dictates that the Dutch coast shouldn't move any more landward. And we call that the Dynamic Conservation Act. And nowadays we use mainly sand nourishment as a means of coastal protection in the Netherlands. Since we have these sand nourishments as a means of coastal protection, it's like the most used way of doing it. There was a lot of research into these nourishment streams, and keeping the coast in place, it resulted in over the years, it resulted in increasing nourishment volumes, in an increasing number of areas, and that led to a shift from nourishment just on the beach or against the dunes to shore-based nourishments, which were developed in the 1980s and 1990s, which are already located a bit further down on the sea, and they are meant to feed the coast in a offshore way. And this idea of providing a more dynamic approach
excavated the well
led to the idea of localized mega nourishment. So we
mainly complete and some
a huge amount of sediment from one location, and we let nature do the spreading for us. At least that's the idea. This dynamic approach is known under a few names like building with nature or engineering with nature from the only course of engineers. Living shorelines or sandscaping. There are a lot of projects now working in this way. But it was not until 2011 that the first implementation of the pilot of such a mega nourishment was attempted, which brings us to the sand engine. On this photo, you see the sand engine as it was constructed. It's a huge peninsula out of sand, which we dredged or nourished towards our coast. And we see this as a new idea for coastal maintenance. It's a very long.
of the Cleveland coastline.
The island is 1 kilometer into sea. That would be 2/3 of a mile. And it extends for 2.5 kilometers along shore when it was installed. In total, the insane amount of 20 million cubic meters of sand was nourished there, and we want to have the redistribution of this sand along an extended amount of coast, about 17 kilometers. We would like to have nature do that for us. So the combined actions of wind, waves, and tidal currents. But besides providing coastal safety, the idea is also that this kind of peninsula can also serve other purposes. such as it can benefit ecology. First, because we don't have to merge every few years. The idea is that this thing will at least serve for 20 years. So we don't have to remerge the code in between. And also in nature, dunes can develop better than recreation. If you have a good eye, you can already see the kite surfers taking advantage of the lagoon. Well, since it's meant to be dynamic, the peninsula rapidly changed shape. Here we see some aerial photographs, and already after 6 months in 2012, there was a huge spit being formed from the peninsula, and well, it at least gave a good indication that sand was being released from that hook-shaped peninsula as it was initially. And in 2013, we see that the amount of sand has stretched further and further along the coast. And in 2016, even further. Since this was a new project, a pilot project, it was decided to also spend a huge amount of attention on monitoring. In this case, it's topography and bathymetry, so the shape of the seabed and the beach. But many more monitoring programs were in place. And so using some kind of vehicles or a jet ski for the offshore area with echo sounding, we were able to make a huge amount of surveys. And this is, let's say, the summary of all these surveys, in which you can actually see the sand moving from the peninsula, which is in the central area. And you see that slightly moving along shore, both to the north, which is to the right of this figure, and to the south, which is on the left of this figure. And we also can see that the breaker bars are being very dynamic in this area. It's because we mainly have a sea, wind-driven waves, which come from varying directions. So after 6 years, the shape of the peninsula was rather different, as you can see from these two comparative snapshots. So what happened to this peninsula? Well, obviously, the extent into the cross-shore it was reduced by quite an amount, more than 500 meters at the moment. Then it's still a bit less. And the sediments from the central area, they are placed on both sides actually of the peninsula, and where they form a spit, or they just fill in the area. And this all seemed to be happening in a rather symmetrical way, which was quite surprising. So if we now look at the difference map, which is shown on top, we translate that into volume change. The central peninsula, that was about 3,000 cubic meters per running meter offshore. So that's quite a huge amount, and most of this was dumped or not dumped, redistributed to the sides of the peninsula. If we look to that in time, we can also see that. So these blue colors that indicates the amount of erosion happening at the central location, which is just in the middle, and then the accretional areas. And in the rest of the coastal cell, there are some varying things going on, but they are orders of magnitude smaller than what happens in the direct vicinity of erosion. So what was striking there is that all the sand appears to be coming from one section, which doesn't grow apparently along shore, and that the amount of sediment supplied to the coast is gradually increasing along shore, and that's one proof that this nourishment indeed speeds adjacent coastal sections. Now, this is only for the first 5 years, but in the meanwhile, the thing has been there for nearly 10 years. So this process is still going on. Well, on the risk of being going too much into detail, we also see that these coastal profiles do change rather strongly. On the left, we see a coastal profile which is on the side of the peninsula, and it has been accreted by 1,400 cubic meters per meter. Whereas on the right, we see the opposite happening, which is the part of the central peninsula, where we can clearly see the coastal retreat happening over there.
Where do you get a lot of
the shape of the coastal profile is actually changing from concave to convex, which is and this led us to see that there are many things going on, and the governing process differs over the
project of this kind of scale.
So on top of the peninsula, we mainly have aeolian transport, and we have some slumping to sand on the outer perimeter through wave action, and we have some occasional beach starts forming over there, which is another story. And the most things are happening actually in wave attack zone, so that's the middle part.
One important one.
Immediate wave action running into the peninsula and redistributing the sand. But below, let's say, -8 meters, below mean sea level, not much is happening there. And that's mainly because the waves are not high enough to reach these depth. So this is kind of a summary where we can see that in 5 years' time, the central peninsula actually has lost 4 million cubic meters. However, these at least 3 million cubic meters are found in the adjacent coastal section. And we also see some seasonal effects happening there. We have very energetic months, usually during our winter season, where much more sand is being displaced as opposed to our relatively calm summer period. And it appears that the alongshore component of these waves is one of the major driving factors, which I won't be addressing too much for now. So actually, we investigated a lot of parameters because, well, we want to make predictions of what is happening to these or new types of negative emissions. And one of the strong correlations is that, well, the amount of alongshore wave power that runs into the peninsula between surveys, that's a rather good descriptor for the amount of volume change happening in a certain part of the coast itself. However, this is mainly on gross volume change, so coastal reshaping. It's not so good with respect to net volume changes in the coast as well, except for this central location where all the erosion is happening. And there are, well, of course, a lot more of these processes that drive sediment spreading. However, we'll still ensure what is the how all the details work. Now, there are many more things to say about this quite remarkable nourishment project. So we occasionally have scarps, but they don't really happen and the very dynamic winter months become, then they are just washed away by storms. We have bar movements, so breaker bars or swatch bars, which have been profiled. They seem to be moving in opposite directions on both sides of the peninsula, or at least they did for a while. Furthermore, we see low contraction of the tidal currents, which is something you would expect if you build something which produces for a kilometer into the sea. And also the dynamics of the lagoon, which was part of the design, are quite remarkable, which is connected through a tidal channel, which extends along shore and occasionally finds a shorter channel again to see.
When it comes to the Great Lakes.
So there's a lot more to talk about. And also in the multidisciplinary sense. The coast is used for recreation quite intensively in the Netherlands because there are many towns close to the sea, and in general, most of the population lives within an hour drive from the beach. So recreation for safety is quite important to us. Also, there has been a tremendous amount of effort into the ecological development of species developing on the peninsula or in the vicinity. And one of the things that we still need to make some improvements on how to predict what is happening to this kind of big peninsula when you put that to the coast. One of the advantages is that you bring the coastal system so far out of, let's say, the equilibrium, that you will get very, very strong signals. And that is what you have seen in this presentation too. So there are some remaining questions also with respect to morphology, things we actually don't know what is happening. In the picture on the right, we see these crown-shaped ridges extending from the peninsula that happened somewhere during summer season, and after that they disappeared again. We don't know how they came into existence. Occasionally we do have some areas which, well, kind of seem to behave a little bit like quicksand. You can walk over it, as you can see, that's no problem. But if you go there with a vehicle, you might get stuck in the sand. And whereas in the initial stage, the peninsula appeared to develop like a Gaussian curve to both sides. It now seems to get more asymmetrical. So are these two parts to kind of separated convex coastlands? Those are open questions which are currently being investigated by some of my colleagues and former colleagues. So as to conclude today, these feeder nourishments, these big feeder nourishments are capable of feeding a much larger stretch of coast. I mean, the sand engine now covers more than 6 kilometers along shore. And whereas it was only almost 2.5 kilometers when it was constructed. And the initial morphodynamic
Yes, so
here is much stronger than in subsequent years. Also, the shore face areas, they react much slower than the intertidal area of the peninsula. So that's something you should look into, and apparently constructing something that protrudes so far into the sea might not be the best idea to get your return on investments with respect to nourished cubic meters of sand. And this increase in scale, we're bringing the coastal system so far out of equilibrium, that it triggers other kinds of behavior, like flow separation, provided currents, sediment sorting. It affects dune growth, etc. And one of the major important conclusions was that the integration of monitoring and research disciplines was actually very important and brought us new insights for future projects. That was all for tonight. I hope you enjoyed the presentation, and you can contact me via the mentioned email address. Paper and data are available via this email. Thank you.
Thank you very much, Bart. I'll give a couple seconds for people to type in any questions into the chat, just like before, and we can go through them. Real quick, the first question I have is, to make this project feasible, where was the sand located, and do you know anything about the testing or some of the requirements that were needed to make sure the sand was going to work? Was there any? Do you know much about that?
Yes. Well, the sand is coming from the Dutch continental shelf area. I mean, the Netherlands, they are located along the North Sea, and the North Sea is a rather shallow marginal sea, so that's our, on average, 20 to 30 meters. So it's dredged from a location about 10 kilometers offshore. And whether it was going to work, this kind of nourishment, it was, well, obviously beforehand there were a lot of numerical modeling studies performed before it was put into place. But, also the Dutch government wanted to investigate this kind of idea, so they were really supportive in making this pilot, which it actually is possible. I hope that answers your question.
Yeah, I think so. I've been involved with a couple projects where a lot of effort was taken in to try and match the grain size characteristics. And with that much sand, I don't know how much flexibility you have, or if there's just a giant sand mine that's available that was convenient, that made it close and made the project feasible.
Yes, it's because the North Sea is mainly, the seabed is mainly consists of sand. So we do have some choice in which sand we dredge up with.
To be more.
And that was matched quite well with the existing sediments.
Okay. Well, I don't see any questions coming in, but we have about 5. Oh, here we got one. Do you know what the range of the grain sizes were used for the nourishment? Did you come across that?
I don't know the exact range, but it was about 250 microns. It's like the medium grain size, if I remember correctly.
Okay. Okay, so we've got about 5 minutes left. So I'm going to pass it off to Nicole Pauly for some final announcements from PIANC US YPCom. And if we have any other time at the end, I think both the speakers said they would stick around, and we can address some other questions if they come in.
Thank you.
All right, yeah, so for some upcoming events and ways to get involved, PIANC USA is hosting a virtual membership meeting in April on the 22nd. The registration will be open in the next few weeks, so keep an eye out for that. This is an opportunity for PIANC USA members to hear updates from the Commission and President of PIANC, as well as listen to a panel discussion on PIANC USA's goals for the upcoming year. YPCom, this group here is planning to host another webinar this summer, and it's tentatively planned for June. And if you have an exciting topic that you'd like to share with the PIANC community, reach out to us and tell us about it. The best way to get a hold of us is to email the website there, and that goes to Kayla. And as Matt mentioned earlier, PIANC USA YPCOM's co-chair position is available, filling Andrea Vitteri's role, which is right now the West Coast region. But we are interested in other regions as well. So if you're interested, apply on the YPCOM USA page at the link on the screen. And the deadline to apply is April 23rd. And lastly, the one that I think is a great opportunity is there are 5 new working group positions available. So join a working group. There are INCOM, NVCOM, and MARCOM Commission opportunities right now, and they are on the USA website. Each working group has a position for a young professional, and deadlines to apply vary by working group by end of March.
So the PIANC's Working with Nature philosophy.
So the link is on the page to apply. And I think that concludes this presentation. I want to thank our presenters for making the time to tell us about these interesting topics. As Vic mentioned, the presenters have offered to hang around for a few more minutes to answer any remaining questions. And if you have any more questions, please type them into the chat, or if you prefer to speak, you can raise your hand electronically, and we can unmute you. Does look like another question has come in. Nick, do you want to take back over?
Yeah, sure. This one is for Bart. In your opinion, what were the main characteristics to make this particular mega nourishment project work? And I guess I'll be more specific for this question is how could this be applied to other coastlines, or can it be applied to other coastlines?
Can it be applied to other coastlines? Yes, I think so. It doesn't need to be this big, though. The general idea of having a nourishment placed on a concentrated location which needs to be spread along a certain stretch of coast is, I think, applicable in many countries or locations. For instance, there is now a pilot being done in the UK, where which is on a much smaller scale. The idea of placing the sand in one location, from which it has to spread towards the rest of the beach. It's stuff being adapted in other places too.
And is this part of the coastline in the Netherlands particularly shallow? I guess as the further you go out, or would you say it's a pretty typical coastline of the Netherlands?
Yeah, and then the question is, what is shallow?
Right.
The coast. There is a gradual decrease. Or there is a gradual increased depth until about 12 meters, and then the seabed becomes rather flat. It's still sloping towards 20 or 30 meters into the North Sea. So it's not particularly shallow. I mean, the outer edge of the nourishment was placed on more than 12 meters water depth.
I want to address a question that I actually, when I would have my screen, I couldn't see the questions. But now that I read more in more depth, Neville Berard asked if there was nourishment would be required in the long term because of the blocks that were connected to the lakefront. This is a great question because yes, if we stabilize the blocks and then put stabilize the shoreline with a hard measure rather than the walkway, there's not going to be that input of sediment coming into the system anymore. But nourishment was required in the beginning of the project to offset this lack of sediment, but it was a one-time requirement that was on for this project. And the other question that I saw about the permitting, that was a very specific question on permitting from Leah. What was time permitting pathway to the Corps of Engineers? I was not unfortunately involved directly on the permitting, but I know that both Army Corps of Engineers and ODNR were involved on this project, and the permitting process took over a year. So I don't know if that helps. I cannot tell you exactly what all the steps were, but there was permitting involved with Army Corps and ODNR.
And then one other question for Bart. What was the tidal range for the sand engine project?
The tidal range varies between 1.5 and 1.80 meters in a mid-spring tidal cycle. It's a 1.80 meter tidal range typically for this part of the coast. And with respect to waves, for instance, in general, waves are about a meter high. Let's say that's kind of average conditions. They are lower in summer, but in winter we can have storm waves up to 5 meters approaching this coast. And that's like the general yearly storm conditions. Of course, more extreme storms will have higher wave conditions.
If anyone wants to raise their hand and ask a verbal question, you just have to activate the participant panel in the bottom right of your screen. If you click on the participant panel and then hover next to your name, there's a raise hand button, and then we will be able to unmute you.
Quick question for Alejandra. You obviously were able to use the physical modeling, which is becoming more and more rare. And forgive me if you went into this already, but I guess what are some of the factors that allowed you guys to proceed with that extra step that we don't see in a lot of other projects?
Money. Sorry. No, really. Actually, one of the key things from our team, because it was a very expensive project, and the city did not have all the means necessary. A big chunk of time that a part of the team spent on was actually to get funding for this project and grants and everything. That also plays a part of why it took so long to actually complete, almost a decade. But we were able to get the funds to take it to lab because of how important it is. If you're going to invest over a certain amount of dollars, you want to make sure that the project, like Mike, works, because the last thing we want is to place something there and then have it not function, and then $20 million later, it wasn't a good idea. So if at all possible, I think complementing with physical modeling is Mohit for hydrogen. If not, there are some other resources like flume channel studies are easier to and are cheaper too. There's a lot of procure. Numerical models are a great tool, but as we've seen in a few projects already, they're not three-dimensional. They don't tell the whole story. So we pushed really hard for includers software available because it was so important for the community. I know that there are several products coming up with 3D numerical modeling. Mike 3 seems to be an example of it. I haven't tried it, but I wonder if that will be a good replacement or a good way to study 3D effects. If you don't have access to physical modeling, that's a thing to consider as well. Did I answer your question?
Yes, thank you.
Okay. And then something comes out.
Do you need more hands raised? Are there any more questions? All right, and if more questions do come up, the contact information is on the screen. So if anyone wants to email the presenters directly, they can feel free to do that. I just want to thank our presenters again. Thank you, Bart. Thank you, Alejandra, for taking time out of your day to share with us about these really interesting projects. I know that I learned a lot, and so we will be posting this on our YouTube site once we get the video edited, if there's anyone that missed anything. But again, we appreciate your time
related to it.
And just stay tuned for future PIANC USA events. Thank you.